Hello, everyone. This week's lab, we are looking at canonical correlations, and we will be using SAS. So the lab document that we have here really just gives you a rundown of how to run this in SAS, what's going on, and then telling you to interpret. As always, this is the link for if you want to look at the documentation. This is how we came up with the syntax. So this will be your friend, especially as we get into other things that you have to figure things out on your own a bit more. Before we get, so today's lab, we're not going to, so for the pre-lab, I mean, we're not going to run it. I'm just going to talk about what is canonical correlation and how to, like, getting everything ready for running it. So here is kind of a general overview of what a canonical correlation looks like. So the x and the y variables, they aren't compared directly. Instead, we use like the variance from them to create these synthetic variables, so which we call canonical variates. One way to think of this, it's not the perfect comparison, but it's kind of like how intelligence is made up of the sum of its parts. It's similar to that idea. So the amount that each variable adds to each of the canonical variates is called the weight. And the relationship between the canonical correlation, the canonical variates, is the canonical correlations. Looking at this just a little bit more simplified, so if we just look at the first canonical covariate, we can see, okay, so for each of our, oh, I went back. For each of our four x variables, they all feed in to, they all add some variance to this first canonical variate. And same with the y. So those are the weights, and then we're looking at the relationship between the canonical covariates. So we're looking at these correlations. And this just continues on for all of the canonical variates. Now, something that's important to note is that each of these canonical correlations is orthogonal. So that means that the variance that's included, so this weight here, it's including only unique variance. Because of this, the amount of variance explained by each canonical canonical variate is going to decrease each time. And that's just how it'll work. So the canonical correlations will decrease each time as the amount of variance left to be unexplained decreases. So this is just kind of looking at both of them, both the first first variate and the second variate together. Now, why are we looking at such a complicated model like this? Well, it's because this is essentially what we've been doing this whole time. I think I've said to everyone before that, you know, an ANOVA is just a fancy way of doing a regression, or all of these different things. But really, everything that we've been doing is just a subset of a canonical correlation. Most of the time, so think of, for a regression, there would only be one outcome variable, one y. Because of that, there's only going to be one canonical correlation. You can only have as many covariates as whichever group, the x or the y's, a number of variables, right? So here there's 4 variables, so you're going to have 4 max covariates. If there was 3 here, then there would only be 3, and there could only be 3 on this side too, because each variate only compares to one other. So in a regression, you just have one outcome variable, and it's related to all of the x's, right? We look at what the weights are that get put in for to make up the one y. So for this model, just imagine that there isn't y2, 3, and 4. That this would look like essentially what we're doing for a regression. So that's kind of the theoretical background of what it is that we're doing and why we're looking at it. Don't get too stressed about it. I believe that there won't be any topic assignments on this. It's pretty much just as a background knowledge for what you're doing, and it also is useful for what comes next. The cats have decided that they are going to make as much ruckus as possible because, of course, they get fed in 30 minutes and they think that 30 minutes should be right now. Leave it. Okay. So now I have SAS open here. Hopefully you are all familiar with SAS. We did use it previously. So hopefully you've been able to get it open and ready to use. I always have trouble remembering how to read my data in for this online version of SAS. We have this syntax. This is for the desktop version. So if we were doing this in the library like normal people in normal times, this is all you would need. So you'd put the path and file name here. Here we're saying we want them to look at these variables, giving labels to the variables, running it, and then making it print it so that we can see that they did it. You can still use this, though the name, you'd have to make sure you name it. But basically, all of this is not useful anymore. We kept it in case you are ever using the desktop version. You can use it then. the SAS version, SAS on demand that we use, instead, it's annoying because it will not read any data that is not already in, that you haven't already added to the SAS system. So what I did was I made a new folder over here. So just here, folder, and I right-clicked on the folder and said upload files. So so this is where I'm uploading the file to, and from there I can actually find things from my computer. So that's how we do that. So I have my data here. Now, the next problem is that if you just try to run the syntax, lines 8 through 12 that we have, when this is open, it doesn't understand. So my way around this, I feel like we taught you something better last time, but here's my janky way of making this work is I just copied this from opening it here and pasted it here. And then it'll work, you know? And then we're going to do here. So lines 8 through 12 is the important ones for this one. And so we have it here. Now we have to still add in the x variable names and the y variables names. So SAS, instead of calling them x and y, they call it var and width. It doesn't really matter. It's doing the same thing. So here we want extroversion, openness, neuroticism, extroversion 2, and conscientiousness. Those are going to be our x variables or var variables. Affective, normative, and continuance will be our y variables. And so these are commitment types for how committed someone, ways that someone is committed to their jobs. So emotionally committed, like I like it here. Normative, well, it's a job, I'm here. And continuance, I've been here forever, I'm going to stay here. So essentially, we are looking at how do these variables predict these variables, right? It's very similar, really, to what we've been doing with factorial MANOVA last week, except now instead of the predictor variable being being categorical, now it's continuous. So, and yes, essentially what we were doing last week was a fancy way of doing canonical correlation. Everything comes back to this if you look deep enough. Okay, so I'm going to let you add these into your data, into the thing here. And then you can run if you want and see if you're able to start interpreting. So my tip for you is to first look at the overall significance, then look at the significance for each canonical correlation. Then you can interpret the canonical correlations by looking at the weights. And how you do that is very similar to how we've been interpreting the discriminant functions, right? So, why don't you start doing this stuff, and then we'll go over all of that in lab on Monday. Okay? Hopefully you have somewhat of an idea what this is. If not, do not worry. It's fine. And hopefully you have gotten your data in and know what to do here. You're ready to run it and start trying to interpret it on your own. And so I will see you on Monday.